So these notes cover log and exponential equations. So remember, the golden rule of logs is if you have log base b of x and it equals some y, then b to the power of y is equal to x. This is the definition of a log, and this is what you end up using in every single log equation or exponential equation. Because if you're solving a log equation, then you convert to exponential. And if you're solving an exponential equation, then you would convert it to a log form. So an example, and we've done some like these already in class, but if you have 2 times log base 3 of 2x minus 9 equals 4, then now I'm going to edit this for a second. First, you need to isolate the log. It's going to be the same here. You'll isolate the exponential. So isolate the log means I want to have nothing on this side but log of whatever. So I'm going to divide by 2 first. So when I divide the left side by 2, 2's divide away, and I just have the log left, log base 3 of 2x minus 9, and 4 divided by 2 is 2. Then I convert it to log forms, or convert it to exponential form. It's already in log form. So log of x equals y, then the base is 3, raised to the power of what's on the other side equals the inside of log. Sometimes arrows help you. So 3 to the power of 2 is going to equal all of this. So 3 squared equals 2x minus 9. 3 squared is 9, of course. Minus 9. Add 9. So 18 equals 2x. Divide by 2. And x equals 9. Right? So next, let's solve an exponential equation. So say we have 2 times 5 to the power of 3x minus 7 equals 50. Now remember, because of order of operations, we can't just say 2 times 5 is 10 here, right? This is 5 to the power of 3x minus 7, then multiplied by 2. So again, in order to solve an exponential equation, isolate the exponential. So we're going to divide by 2, and we get 5 to the power of 3x minus 7 equals 25. Now we're going to convert it to log form because it's an exponential equation. So b raised to the power of y equals x, that means I'm going to use log, with 5 as my base, of 25, right? Because 25 was what it equaled, so 25 now goes inside of my log. Log base 5 of 25 equals 3x minus 7. Now, what's log base 5 of 25? Think 5 raised to what power equals 25? Did you say 2? I thought I heard you say 2. 2 equals 3x minus 7. Now at this point we just solve like normal. So 9 equals 3x, divide by 3, and x equals 3. Alright, let's do a slightly more complicated example. Say we have 2 times log base 2 of x minus log base 2 of 2x equals 3. Now, it's a log equation, so my goal is to isolate log, but I need to only have one log. Here I have 2 of them. So I'm going to use log properties to simplify the expression until there's one log. So I have 2 times log base 2 of x minus log base 2 of 2x. Go and get out your log property sheet. Now, there's one property that says if I'm subtracting logs, I can divide the inputs. But I need to deal with this 2 first. There's another property that says when I have coefficients, I can move them into exponents inside of log. So 2 can be moved to an exponent here. And I end up with log base 2 of x squared minus log base 2 of 2x equals 3. Now I can apply the subtraction property. So I get log base 2 of x squared over 2x equals 3. Now I have one log. So I convert it to exponential form. 2 to the power of 3 equals x squared, or one thing I can do in here, almost forgot. X squared over 2x. This simplifies to log base 2 of x over 2, right? X squared divided by x becomes 1x over 2. Now I'll convert it to log form. So I have 2 to the third power equals x over 2. 2 to the third power is 8, right? So we have 8 equals x divided by 2. Multiply both sides by 2. And I get 16 equals x. Let's do one last one. And this one will be another exponential equation. Here I have 5 to the power of 2x equals 20. So this really isn't that bad, even though, so 20 is not a perfect power of 5. So we know right away this answer is not going to be a whole number, or even a rational number. And this is because 20 is not a power of 5, at least not an integer power of 5. But we still apply the same property. It's an exponential equation, so we're going to convert it to log form. So we're going to have log base 5 of 20 equals 2x. Now, again, log base 5 of 20, not a rational number. So we're going to leave it in its exact form, log base 5 of 20. So this is a number, it's an ugly number, but number nonetheless. So we divide both sides by 2, and we get x equals log base 5 of 20 divided by 2. Now at this point, if you wanted to know what the decimal was, this is when you would want to round it. So log base 5 of 20 divided by 2 is approximately, remember squiggly equals means approximate, 0.93. So the answer is not a whole number, like I said, or not even a rational number. This decimal goes on forever. But you still solve it the same way. We convert it to exponential, and then we divide it by 2. Okay, that's going to be it for the log and exponential equations notes for now. There will be a part 2 coming soon. All right.